The final section in Chapter 9 is hypothesis testing for the population proportion P. So in this case, what's going to happen is we're still going to determine the null and alternative. We're going to calculate, the test statistic with a different formula. We're going to calculate the p-value using Excel, compare the p to alpha, and make a decision. So the main difference is going to be the different formulas. Now, it is important to note that we have to make sure we can approximate this with the normal distribution, and so we have to consider these two items before we kind of move on. And usually if n is really, really large, then we don't really need to worry about that. So for the test statistic, it's a z-score, and we're going to use the population proportion to figure out, the sample proportion to figure out the population proportion. So this is the deal. We're going to do the null and alternative. We're going to make sure we have our alpha, calculate this test statistic using this data here. Then we're going to use Excel, and we've actually seen this before. And then if the p is low, the null must go, and interpret in the context. So a popular weekly magazine asserts that fewer than 40% of households in the U.S. have changed their lifestyle because of environmental concerns. A recent study of 180 households finds that 67 have made lifestyle changes. Specify the competing hypothesis to test the magazine's claim. All right, so we know we're dealing with proportion because we've got that percent, so 0.40. And it says fewer than. Fewer than does not have equality, so that becomes our alternative. And so this magazine asserts this. This is the magazine's claim. This is the magazine's claim. And so the contradiction of less than is greater than or equal to. So that's that. Now, to calculate our test statistic, it is a z now. And the formula for that is right here. So we need to get our sample proportion. This is the formula, our sample proportion minus the proportion in question, all over the proportion in question, 1 minus the proportion in question, all divided by n, and it's square rooted the whole thing. So what is our sample proportion? Well, they tell us that of the sample, 67 of 180. So when we do 67 over 180, we get 0.3722. And our, proportion in question is this 0.4. And our n, in this case, of the sample is 180. So to calculate this, we would do 0.3722 minus 0.4 all over big square root 0.4 times 1 minus 0.4 divided by 180. So just be super careful when you type this into your calculator. So I'm going to do the bottom first. So 0.4 times 1 minus 0.4 divided by 180. And then I'm going to square root this answer. And then what I'm going to do is the top. And if you don't like this, that's fine. But it just helps. Oops. Sorry about that, y'all. It just helps me. The top divided by the answer we got previously. Oops, what did I do? I missed oh, that's why. Minus 0.4 divided by the answer. So we get our test statistic here is going to be negative 0.76. So if we think about this for a moment, we have, where can we put this? We know it's a negative 0.76, so let's look at our alternative. That is a left-tailed, so we can do this over here. That's great. We can just go straight to Excel to get our p-value the way we've done in the past without having to really worry too much about it. So this is norm.dist, and our x is negative 0.76011. And so our p-value is 0.2236. So at the 5%, so 0.05, if our alpha is 0.05, what is the conclusion? So now we need to compare our p to this. So our p is 0.2236, and we're trying to compare it to 0.05. First digit, it's already larger. So if the p is low, the null must go, so we do not reject the null. The p is not low. So if we do not reject the null, we essentially accept the null, so we cannot conclude that fewer than 40% change their lifestyle. So here it is all written out for you. And let's do another example. Driven by growing public support, the legalization of marijuana in America has been moving at a breakneck speed. To date, 57% of adults say the use of marijuana should be made legal. A health practitioner in Ohio collects data from 200 adults and finds that 102 of them favor. The health practitioner believes that the proportion of adults who favor marijuana is not representative of the national proportion. Specify the competing claims. So we know we're dealing with proportions here. So P and P, and the national average is 0.57. So this practitioner believes that it is not the same. So that would be different than, and that would be the claim. So the test statistic, our test Z, so for our test Z, we need our sample proportion. So our sample proportion is 102 out of 200. So when we calculate 102 out of 200, we get 0.51. And then our P in question, our proportion in question is 0.57, and N is equal how many people? 200. So when we calculate our test statistic here, and I'm actually going to do it over here, we're going to do our sample proportion, 0.51 minus the in question value, all over the square root of 0.57, 1 minus 0.57, all over 200. So go ahead and type that into your calculator. And when you do that, you should get negative 1.71. So that is our test statistic. That's the test statistic. What that looks like is it's negative 1.71. Now, the type of tailed test is 2. So because it's a two-tailed test, we know that it's going to be over here at the positive and over here. So it's 2 times this amount here. But this amount is left-tailed because it's negative, so we can just do 2 times whatever we get inside here. So it's going to be 2 times norm dot dist of negative 1.71011. So our p-value is equal to 0.0873. So now at the 10% significance level, so that's B. At the 10% significance level, 0.10, does it support their belief? So let's compare our P to the significance level. First digit, 0 and 1. This is smaller. If the P is low, the null must go. So we're going to reject the null. If we reject the null, we're saying we agree with the claim. So we can say that we support the claim. The evidence supports the claim. Supports the claim that it differs. And here it is written out for you. And we'll do one more together before you try some on your own. Nearly 1 in 3 children and teens in the U.S. are obese or overweight. A health practitioner in the Midwest collects data on 200 children and finds that 84 of them are either obese. So nearly 1 in 3. Believes that the proportion is not representative. So this is super similar to example 2. So what are our competing hypotheses here? So we know that we're talking about P and 1 in 3. So we could say 0.33 or 1 out of 3. It doesn't really matter. We'll do 0.33. So the national average is this. They believe that it is different. So not equal to. That's the claim. And then this would be equal to. So the value of the test statistic only they're interested in. So for the test statistic, we need the sample proportion. So that's 84 out of 200. So that would be 0.42. And the N we need, which is 200. So for the test statistic, that's going to be 0.42 minus 0.33 over the square root of 0.33 times 1 minus 0.33, all over 200. So type that in carefully. We should get 2.71. So when we do that, that's the test statistic. C says, at the 1% significance level, can you support the health practitioner's belief? Well, you need the p-value to do that. Even though they didn't ask for it, you've got to find it. So this is 2.71, so that's over here. And this is a two-tailed test. So this is the p-value if we type this in, but we really are going to do 2 times because it's a two-tailed. And because this is positive, we know, and it's going that way, we know it's going to be 1 minus this amount. So to find the p-value, and yes, you could use the negative. It is a little bit easier. But just to follow with the rules that are posted earlier. So if we're doing 2.71011, oops, they always add an extra parenthesis. I always forget it. We get 0.0067. So our p-value is 0.0067. How does that compare to 0.01? First digit, same. Second digit, 0 and 1, this is less than. If the p is low, the null must go, so we reject the null. We reject the null, and that means we support the claim. So can we support their belief? Yes, we can support their belief at the 1% level. Oops. All right, go ahead and give these 2 a try. Press play when you're ready to see the solution. And that concludes Chapter 9.